Today we're going to look at some stoichiometry problems, and we're going to solve them using stoichiometry and molar relationships. In this first problem, we are asked how many moles of water. So I'm going to write a question mark down there, how many moles of water. And then we're told that we have 3 moles of oxygen gas. So I'm going to write underneath here 3 moles of oxygen gas. Now, in order to solve this, we're going to use some ratios. So here, there's an invisible number 1. So I'm going to write an equation that says 1 over 3 moles is equal to 2 over x. So the top part of my equation here, right here, this came from the chemical formula. All right, those are my coefficients. The bottom part here is from the problem itself. Those are the moles that we are given in the problem. Now, in order to solve this, we are going to cross multiply. 3 times 2 gives me 6, and 1 times x gives me x. So the answer to this problem is 6 moles of H2O. Now, if you look, the problem actually told you the answer in advance. It tells you that for every 1 oxygen, you are going to need 2 waters, or you're going to actually produce 2 waters. So whatever you're given in terms of oxygen, you can just double it, right? Because 1 is to 2, that's a ratio that means double what you're given. So if I was given 3 moles, I'm going to double that and get 6 moles of water. Okay, let's try this again. So in this problem, it says, for the following balanced equation, how many moles of sodium metal are needed? So I'm going to write in a question mark here, how many moles of sodium metal, if we're going to react with 2.3 moles of zinc chloride. So I know that this one is 2.3 moles of zinc chloride. So I'm going to write a formula again. I'm going to put my coefficients up top. So I have an invisible number 1 again. So I can say 2 over x moles is equal to 1 over 2.3. Again, now that we have a ratio written out, we can cross multiply. So I'm going to cross multiply here and get x, because x times 1 is just x, and 2 times 2.3 is 4.6 moles. So if I take these things, 2 times 2.3, I get 4.6. Now, if I look back at the original equation again, I have a 1 to 2 ratio again, right? So I need to multiply whatever this is by 2 in order to make it work out properly. So if I could take a shortcut here and just take this number and multiply by 2. Okay, let's do one more of these before we move on to a different type. So in question 3 here, you're told how many moles of oxygen. So we're going to, underneath the oxygen here, we are going to write how many moles. So I'm going to write question mark moles of oxygen are needed to produce 8 moles of aluminum oxide. So I know that I have 8 moles of aluminum oxide. Let's build some ratios and move forward on this thing. So the equation, the coefficients up top here are 3 and a 2. So I'm going to write a 3 up top and a 2 up top right from the equation. And then from the problem, I know that I'm looking for the number of moles of oxygen, and I'm given 8 moles of aluminum oxide. So again, we're going to cross multiply. And this time I'm going to get 2x equals 3 times 8. 3 times 8 is 24. I can't leave it like this time. I need to get x by itself. So in order to do that, I'm going to divide both sides by 2. And that's going to give me x equals 12 moles of O2. Now this one isn't as straightforward. How do you get from a 3 to a 2? it's not immediately obvious what you would have to do. But actually, if you did 3 times 2/3, you would get 2. And so another way to solve this problem is to say, well, what is 2/3 of 8? Oh, no, sorry, I said that backwards. So what times 2/3 will give me 8? Is actually the correct way to look at that. This math might be a little rougher, but you can do it. To get the question mark to the other side, or to get the question mark by itself, we're going to multiply both sides by 3/2. That will cross out my fractions, and I'll be left with x equals 24/2, which is 12. Okay, now let's add another step to one of these problems. Sometimes the problems that you're given will need to be balanced first. So let's review balancing equations before we get started. In this first problem, I'm going to balance it by listing all of my elements. So I have a copper and I have an oxygen on the left side, and I have a copper and an oxygen on the right side. Now I'm going to look and see how many I have. So I have 1 copper on the left and 2 oxygens on the left, and I have 1 copper on the right and 1 oxygen on the right. So the coppers are okay. I have 1 and 1, but the oxygens are not. I have a 2 and a 1. So I need to multiply this one by 2 in order to make them even, to conserve atoms on both sides. So I need to put a 2 up top here. But when I do that, that means I'm also going to be multiplying the coppers by 2, which will mean that I have 2 coppers. Well, that's a problem because I only have 1 copper on the other side, so I will need to multiply that by 2 as well. Okay. If you want, you can fill this blank in with a 1. That's fine. That is perfectly acceptable. Some people will leave it blank because it's understood that there's a 1 if it is blank. Okay, now we know it's a 2-1-2 relationship, and I'm told that I have 7 moles of copper 2 oxide. So underneath here, I'm going to say I have 7 moles of copper 2 oxide, and they're asking me how many moles of copper did I need to start with. So let's build our ratio just like we did the last time. 2 and 2 are my coefficients right from the problem, 2 and 2. And I was told that I have 7 moles on the right over here, and I'm looking for x moles over here. So 2 over x, this arrow is like an equal sign, and equals 2 over 7. So 2 over x equals 2 over 7. I can cross multiply 2 times x equals 2 times 7, which is 14. Now to get x by itself, I need to divide both sides by 2, or I can say that x equals 7 moles. Now, there's a trick here. Both coefficients are 2. That can be reduced to a 1-to-1 ratio, which means any number of moles that you have on one side have to be exactly the same as the moles on the other side. So a 2-to-2 relationship is the same thing as a 1-to-1 relationship, and it's the same thing as a 7-to-7 relationship. So anytime you have equal numbers on both sides, you can treat it as if it just says keep the same number. Okay, let's try and balance this next equation. I've got 2 elements again, iron and chlorine, and on the left I have 1 iron, and on the left I have 2 chlorines. Over here I have 1 iron, but over on the right I have 3 chlorines. Now, the irons are fine. I have 1 on both sides, but the chlorines are not. I have a 2 on the left and 3 on the right. Now, anytime you have an odd and an even combination, it's difficult to deal with unless you multiply the odd number by 2. So we're going to multiply this by 2 and get 6. Okay, so I'm going to multiply by 2 by putting a 2 on the coefficient blank in the front there. Okay. Okay, so now I have 2 sets of 3, that's 6 chlorines, but I also have 2 irons, so I have to multiply this by 2 as well. Now, in order to get 2 irons on the left side, I'll have to multiply it by 2, so I'm going to need to put a 2 there. And I'm going to need to get 6 chlorines on the right, or sorry, on the left. In order to do that, I'm going to need to multiply by 3. So I'm going to put a 3 right there on that block. So 2 irons on the left, 2 irons on the right. That's good. 3 times 2 gives me 6 chlorines, and 2 times 3 gives me 6 chlorines. So everywhere I go, I have the same number of atoms of each element. So now the problem says, if you would like 4 moles of chlorine, so I'm going to box this up here. I'm going to say that I have 4 moles right here, 4 moles of chlorine. It says how many grams of iron. We're actually going to answer that in terms of moles this time. So how many moles of iron must you add to the following reaction? So I'm going to put X moles right here, because iron is going to be how much? Okay, now we need a ratio like we did the last couple times, and we're going to set it up with our coefficients on the top and what the problem gave us on the bottom. So 2 and 3 are my coefficients, they go up top, and X and 4 go on the bottom. Let's cross multiply, and we get 3x equals 2 times 4. 2 times 4 is 8. I need to get x by itself, so I'm going to divide both sides by 3, and I'm going to get x equals 8/3. But this is chemistry, we really don't like to leave things like that. I'm going to turn it into a decimal, and I'm going to get 2 and 2/3, or 2.7 moles, since I'm going to round my 0.6666 off to a 0.7. Okay, there are a few more questions for you to answer on this worksheet. Good luck, give them a try.